Hello everyone, this is the lecture series of Operation Research subject and the course or code of this subject is ME405. This is the subject comes under BTech Mechanical Engineering 7th SEM in the Suresh Gyan University, Jaipur, and present time unit number 4th is running and lecture number is 27, and today I will discuss about the EOQ analysis. And EOQ analysis just like economic order quantity analysis, and this is comes under the inventory management topic. And in the inventory management different types of analysis are given. First one is ABC analysis, EOQ analysis, and XYZ analysis. Different kinds of analysis are comes under this. So in all types of analysis today I will discuss only EOQ analysis. And for my introduction, myself Rahul Kumar, Assistant Professor of Mechanical Engineering, Suresh Gyan Vihar University, Jaipur. And for this case of EOQ analysis, in stock management, economic order quantity is a very important inventory management system that demonstrates the quantity of an item to reduce the total cost of both handling of inventory and order processing. And the purpose means the main purpose of this EOQ analysis to determine the EOQ means economic order quantity, is to minimize the total incremental cost. Total incremental cost, this is a TIC, and beyond the cost of purchasing of the product or material in consideration of two main total costs. The ordering cost TOC and the total handling cost THC, which gives the two types of highlight and two basic methods of determining EOQs. One is trial and error method, and another one is mathematical approach, and emphasizes the mathematical model as highly useful to enhance the inventory management of a product. And this is used in stock production also. And it is very important management tool for the system that demonstrates the quality of an item to reduce the total cost, and for both handling and inventory, and it reduces the processing order cost, and it also reduces the time of the order. And the purpose of determining the EOQ is the minimize the total increment cost, right? It minimize the total increment cost, and this will affect the total ordering cost also. And here in this lecture I will discuss the different kinds of error methods and the mathematical approach, and emphasizes the mathematical model as highly useful to enhance the inventory management of a product. So we go to the objectives of the topic. So for this objective, for the end of this chapter and our session, the student should be able to understand about and it provide the acceptable level of the customers on time of delivery, and it also give the allow cost efficient operation. And the main purpose of this EOQ analysis, it minimize the inventory investment. So this is the main purpose of this EOQ analysis. And next thing is here, this gives the critical understanding at the development of reagents, tools, and the different types of products, or we can say that new products comes under this category. So this is very important tool for the analysis of reorder cost and reorder time, So with this analysis, it means estimate or it reduces the reorder time, right? And it also manages the stock in the warehouses for the raw material case, right? These are the different type of inventory in supply chain. First is here raw material. This is the raw material, just like as if you want to obtain one company. This is a bike company. So here the bike company is here. First is sheet metal, tire, and some small components, a screwdriver and equipment also. These are the raw material of this raw material of the final product. And the components like as a engine manufacturing company, you assemble the engine, so you want some components like piston rings, piston head, and the some component like inlet and outlet, timing valve, spring, and different types of components related to this purpose. So here you take different components. And third inventory is here. Inventory in the supply chain. This is the work in progress inventory. This is the WIP. This is used in the software field or the development of the small component like this. This is the, here is one cardboard is given, and just here one type of microchips inside this. So here is this type of inventory is work in progress, WIP inventory. And this is the finished goods inventory. Finished goods means completion of the goods. Suppose you make a one bike or car or truck or a computer or mobile. This is the finished goods inventory. And how to sell this? And the last next is here distribution inventory. Distribution means transportation the goods from one city to another city. This is a one type of inventory, and it also clear the maintenance, repair and operating supplies, MRO. MRO means in any company one unit is here, overall and repair maintenance division, or this is sometimes called the MRO division, and it have a expertise member which have a different types of tools, and some critical operations are done. So these are the some kinds of inventory. These inventories are raw material, component, work in progress, finished goods, distribution inventory, and maintenance, repair and operating supplies, MROs inventory. These are the 6 kinds of inventory related to this EOQ analysis, right? And then move to the next type of inventory. This is introduction of this EOQ analysis. In this slide, this shows the some independent and dependent demand, and some products are independent to other products, and these items are finished goods or other items sold to someone outside the company. So this comes under the independent demand of the item, and some items are dependent demand item. These items are material or components, parts used in the production of another items. Example, finished products and other thing. So these kinds of items are related to this inventory level. So these are the 2 types of item. First is independent item and the dependent item. Suppose the computer chips and the computer, this is the dependent item. And in the case of independent item, suppose in a one piece of bike or any other thing, this is the independent item. So these are the some other inventories related to the EOQ analysis. These are the anticipation of the seasonal inventory and safety stock, buffer demand fluctuations, and lot sizes or cycle stock. This is a one type of warehouse inventory, and it takes advantage of quantity discounts or purchasing efficiencies. And next is pipeline or transportation inventory. Pipeline or transportation inventory and speculative or hedged inventory protect against some future event, example labor strike. And last thing is here maintenance, repair and the operating MROs inventory. This is the last thing of inventory. So these are the different kinds of inventory related to this EOQ analysis, right? These are the some relevant inventory cost. These are the item cost, holding cost, ordering cost and shortage cost. These costs are related to the EOQ analysis. So first I am going to explain about the item cost. Item cost, this is a cost per item plus any other direct cost associated with the getting the item to the plant. And the holding cost, just like this is a capital, storage and risk cost, typically stated as a percentage of the unit value. Example, this is the value of 15 to 20%, 25% of the total value cost. And the last thing is here ordering cost. This is the fixed cost of the item and it gives the constant dollar amount or the in India in rupees amount incurred for each order placed. And this is cost of the order. At the time of order, the product is make some cost. This is the ordering cost and this is the shortage cost. Shortage cost just like the loss of the customer's goodwill. Means sometimes some items are short in your company. So at this time you purchase this item immediately from the other type of other company. So you will take the item at the high rate. You will take this item at the high rate. This is the cost of the product is called the shortage cost, and this gives the loss of the customer's goodwill and back order handling and the lost sales also, right? So these are the different kinds of shortage cost related to the relevant inventory cost related to the EOQ analysis. And these are the different types of order quantity strategies. These are the lot for lot. First is order exactly what is needed for the next period, and this is the lot for lot strategy. And the fixed order quantity. Fixed order quantity, you want to fix order. Suppose after 10 days you will take 20 items for this product. So this is the fixed order quantity, and the consumer deliver your after 10 days 20 piece of this item. So this is the fixed order quantity, and this is the order a predetermined amount each time an order is placed, right? And the second third thing is here minimax system. For the minimax system, when an hand inventory falls below a predetermined minimum level and order enough to refill up to maximum level. So this is the minimax system value. And the order n periods. Order of the n periods. This is the order enough to satisfy demand for next n period. So this is the order of the n periods. So next we think about this. These are the different types of order quantity strategies related to the EOQ analysis, and then move to the examples of this ordering approach. Examples of the ordering approach. Here the different types of examples, just like as a lot of the lot example. Here the requirement is just like as a 70, and the project on hand, this is the 30. This is like this, and order placement, this is a 40. But here requirement is 70, but you place order here 40. This will create some disturbance in your order, and here is 70 requirement. So here you will place order 70, and just like this, right? So for the lot for, this is the lot for lot example, right? And this is the fixed order quantity example with order quantity of 200, with order quantity of maximum order quantity of 200. Suppose you fix the order some period of time. Suppose you fix this is the 200 quantity of order place here. Suppose here want this type of product. So, and in this case again 200 quantity and again 200 quantity. This is the example of the fixed order quantity example with the order quantity of 200. And this is the min-max example with the minimum 50 and maximum 250 order is placed. In between 50 and 250 you place the order. And this is the requirement, this is the project on hand, and this is the order placement. This is the 220, 140 and 180 is here, and then 160 is here. Here the order n periods with n equal to 3 periods. This is the requirement of 70. This is the requirement, different types of requirement. But here order is placed as a definite period, just like 175 in this period, 200 and 160. So this is the different kinds of example related to the ordering of this EOQ analysis. Then move to here the 3 mathematical models which given the mathematical determine the order quantity, and these mathematical model are economic order quantity, EOQ or Q system analysis. And next is here the economic production quantity. This is the EPQ. And third is here quantity discount model. Third is here quantity discount model. For this economic order quantity, it is an optimization method. This is used for determining order quantity and reorder points, and it is a part of continuous review system which tracks on hand inventory each time and withdrawal is made for this type of inventory. And this is the third case is here economic production quantity. This is the EPQ, a model that allows for incremental product delivery. This model always deliver the incremental product delivery. And the third is here quantity discount model. For this quantity discount model, it modifies the EOQ process to consider cases where quantity discounts are available. So these are the 3 types of models. And then this is the economic order quantity. This is the economic order quantity, and these are assumptions we have taken it here. For the EOQ assumptions are these are demand is known and constant, no safety stock is required, and lead time is known and constant. Lead time is known and constant, and no quantity discount are available, and ordering cost are here. We have used one assumptions. For this case, ordering cost are constant, and this ordering cost satisfied the all demand, and here is no shortages, and the order quantity arrives in a single shipment. Here the order quantity is arrived only a single shipment. So in these cases, this graph shows in the x-axis shows the time, and this y-axis shows the order quantity. Is how much order you want to put here to the consumer. So this is this point shows the reorder point, right? And this is the minimum inventory level equal to 0, and this 0 shows the minimum inventory level case. So move to the next slide. Here are the different costs associated for this case, and these are the TCEOQ. EOQ, this is the total cost. TC is the total cost, and this is the given by the sum of two quantities. This sum of the this is the D by Q into S plus Q by 2 into H. So where TC represent a total annual cost, where the TC represent a total annual cost, and D represent the annual demand, and Q is the quantity to be ordered. Q is the quantity to be ordered, and H is annual holding cost. H is the annual holding cost, and S is ordering or setup cost. Ordering or the setup cost for the S case. So these are the different types of cost associated with EOQ analysis. So for the case of ordering cost, right, and it is the cost that are incurred on obtaining additional inventory. Obtaining the additional inventories, they include costs incurred or communicating the order, traveling allowance and the daily allowance to purchase officers, printing and stationery, salary of purchase department, and cost of the inspection, cost of the receiving the material, and transportation cost, etc. And all above cost related to these items and other than transport cost remain unchanged per order in respective of the order cost, and therefore it is assumed that ordering cost per order remain constant. The more frequently order are placed and favor the quantities purchased on each order, the greater will be ordering cost, and vice versa. This relation is shown in the figure in the next slide of this figure. Like here is, this is the ordering cost. If order of quantity is increases, if the order of quantity is increases, then this cost is continuously decreases, and this cost is continuously decreases, but holding cost is increases annually. And this is the curve is called, sometimes curve is called the bathtub curve. So this is represent like as a bath or the parabolic curve, and this represent the total cost, and the total annual cost of this item is here. This is the annual ordering cost plus annual holding cost. And for this here in this graph, y-axis shows the annual cost and the x-axis shows the order quantity, means economic order quantity, and here is this very least point or the cut point of this holding cost and the ordering cost. This gives the EOQ point. This is the economic order quantity, and the economic order quantity, this is one type of model, and this gives the, and this model is used as a economic order quantity model because it established the most economic sizes to order to place, and it is one of the oldest classical production scheduling models. And in 1913 Ford W. Harris developed this model, whereas R.H. Wilson is given the credited for the application and in-depth analysis on this model. By using this model, the companies can minimize the cost associated with the ordering and inventory holding, and it can be valuable tool for small businesses owners who need to make decisions about how much inventory to keep on hand, and how many items to order each time, and how often to reorder in incur the lowest possible cost. And there are two most important categories of inventory cost, are ordering cost and the carrying cost. So here is the order size. that minimize the total annual cost. Here the order size that minimize the total ordering cost. And economic production model, second model is here economic production model, and third is here quantity discount model. Means three models are required to economic order quantity, just like as a economic order quantity, EOQ model, economic production model, and the quantity discount. These are the some more assumptions of EOQ model is here. Only one product is involved and annual demand requirement known. In this case, annual demand requirement is known for this case, and demand is even throughout the year, and lead time does not vary, and each order is received in a single delivery, and inventory level equal to 0 when new order just arrived, and there are no quantity discount. Here there are no quantity discount is used. So this is the assumptions of the EOQ model. Here this graph shows the x-axis shows the time, and this is the Q. For this this Q is the quantity on hand. Suppose at the present time this is the maximum quantity on your hand, or this is the maximum quantity, or in this your warehouse, and this is the reorder point. This is the reorder point. So this point shows the reorder point. In this reorder point, and just this is a horizontal line which is parallel to the x-axis. Suppose just here this line shows the usage rate, and this if your item is just time is goes on and time is increasing, then the usage rate it falls down, and it goes on the reorder point, and after the reorder point you place the order here, and at this point suppose this usage rate is going to 0, at this point you again receive this order. So at this time use quantity on hand is again this much. So this is again then repeat this step. So for this system, suppose you want to do order at this point, so this time you have a quantity in this hand, and accept this order this at this time, so again you have a quantity on hand at the same time, and this is the profile of inventory level over time. This shows the profile of inventory level over time. So these are the different kinds of inventory cycles, and for this purpose, and this is the some terms. This is the without safety stock. This is the R equal to DL, where R are the reorder point in units, and D is the daily weekly demand in units, and L is the lead time in days or per week, and the with safety in stock then gives the R equal to DL plus SS. So SS shows the safety stock in unit. This is the safety stock in unit, and next thing is here. These are the some other formulas. The adjusted total cost, DCQ equal to DEQS plus I max 2 into H, and the maximum inventory, this is the I max equal to Q1 D by P, and this is the adjusted order quantity. This is the EPQ equal under root 2 DS divided by H1 into D by P is here. So these are the different order quantity formula to use here, and this is the one example related to the EOQ analysis, where the weekly demand of unit is 240 units and number of weeks per year 52, and ordering cost is here $50, unit cost is here $15, and annual carrying cost, this is charged by a 20%, and lead time here 2 weeks. So you can manage this type of things here, and how to solve this question, we move to the next slide. And this is the EOQ example solution, and here the D equal to 52 into 240 equal to 12,480 units per year, and H equal to 0.2 into 15, this is the $3 per unit per year, and here Q equal to under root 2 ds divided by H is equal to under root 2 into 12,480 into 50 this divided by 3, and this is equal to 644.98, and this is equal to 645 units, and the total cost is here D by Q into S plus Q by 2 into H, and you already know this formula for this total annual cost and put the values for this formula. So this is the values are here. D equal to 12,480 divided by 645 into 50 plus 645 divided by 2 into 3, and this is a total cost is here 967.44 plus 967.5. This is a $1,934.94, and then R equal to D into L. This is a 240 into 2 equal to 480 units. This is a 480 units for this case. Then move to the next slide. And this is the EPQ analysis. This is the EPQ analysis. This is the economic production quantity and assumptions, and same as the EOQ expect inventory arrives in the increment and is drawn down at its arrives. So here is y-axis shows the number of units and x-axis shows the time of days. So suppose these are this dotted line shows the unit produced equal to Q by P, and this line solid line shows the 0 to here inventory build up, and this is the maximum inventory level equal to Q1 minus D by P equal to I max. This shows the I max value, and for here this length gives the inventory depletion region, and this is the I max divided by D is here. So what is the D in this case? D just shows the D is the annual demand, right? D is the annual demand for this case, and so the order quantity is here 2000 units. So here is order quantity is here 2000, but daily demand is only 100 units, and daily production of this P is equal to 250 units. So the replacement of order cycle is here 20 days for this case, right? So move to the next. So this is the second question, and in the second question annual demand is here 18,000 units and the production rate is 2,500 units per month, and setup cost is equal to $800, and annual hand holding cost is here $18 per unit, and lead time equal to 5 days, and number of operating days per month is here 20. This is the number of operating days per month. So we move to the next EPQ example solution. This is the D equal to 18,000 divided by 12 because we want to demand in per month. So 1500 units demand is per month. So P is equal to 2,500 units per month. This is the production rate. So Q equal to already you know the formula. Find the Q value. Q equal to under root 2 ds divided by H1 minus D by P. So it is equal to 2 into 18,000 into 800 divided by 18 into 1 minus 1500 divided by 2,500. This is equal to the 2,000 unit in this case. For this case I max is here. I max is uses the formula equal to Q1 minus D by P. Q1 minus D by P. This is equal to 2,000 into 1 minus 1500 divided by 2500, and this is equal to 800 units. So this total cost is associated with already you know the formula is here, total cost equal to D by Q into S plus I max divided by 2 into H, and this is equal to 18,000 divided by 2000 into 800 plus 800 by 2 into 18. So the total cost is here 7,200 plus 7,200 equal to 14,400 for this case. So this is the answer of this question. The total cost is here 14,400 of this order quantity. And then find the value of the reorder point. If you find the value of reorder point, then you will use this formula, R equal to D into L. This is equal to 1500 divided by 20 into 5. This is a 375 units with safety stock of 200 units. With safety stock of 200 units, then you take a formula R equal to D into L plus SS. This is equal to 1500 divided by 20 into 5 plus 200. This is equal to 575 units. So this is the answer of this question. This is the reorder value at the reorder point, and this is the reorder value with safety stock of 200 units. Means this shows the if you have stock of 200 units. So what is the reorder point? So reorder point is here 575 units for this case. So we move to the next question problem. This is the next problem, and here the annual demand is here 5,000 units and ordering cost is $49. Annual carrying charges 20%. So unit price schedule. This is the quantity. These are the quantity 0 to 999. This is a unit price of $5. And if a quantity is 1000 to 199, and this is the unit price of $4.80. If quantity of the item is increases just like 2000 and over, then the unit price is 4.75. So the conclusion of this question here, if you increase the quantity, then reduce the unit price, right? Reduce the unit price. So this is the step 1. This is a solution of if ordering quantity of the product just like if value of $4.75, then it uses the formula, then it gives the 2 into 5000 into 49 divided by 0.2 into 4.75 equal to 7118. This is the not feasible. And for the case of next case, and QP equal to $4.8, and for this case 2 into 5000 into 49 divided by 0.2 into 4.8. This is the 714. This is a not feasible solution. And then move to the third case. Here the QP equal to $5. For this case it will give a solution of 700. So this is a feasible solution for this case. Then move to the next step of this problem. This is the step number 2. For the step number 2, this is the total cost if Q equal to 700, Q equal to 1000 and Q equal to 2000. Total quantity is like this. So it will give say value of TCQ 700 equal to this, apply this formula, and it will give a value of $25,700, and TCQ 1000, this is a $24,725, and TCQ 2000, this is a gives the value of $24,822.5 for this case. So these are the different kinds of quantity order example, or this is the best solution for this problem is here, right? So this is the safety stock example. Just you note down this example and solve this example at the like as a homework, right? Like as a homework, and this graph shows the different types of analysis. This is the inventory on hand and distribution of daily demand and distribution of the lead time demand. This is the service level. Here is risk is associated with it, and this time is the lead time, and this is the safety stock. And then after this we move to the next section of this lecture. This is the MCQ section. Then move to the MCQ problem. This is the first MCQ question. For this question, which among of the following is a type of inventory system, and that is used to manage independent demand items? And option is here: A is order point system, B is material requirement planning, C is time phased order point, and D is enterprises resource planning. So the correct answer of this question is C is the time phased order point. C is the correct answer of this problem. This is question number 2. An effective inventory management minimize the investment of the inventory by effectively meeting the functional requirement, customer requirement, process reliability, sales forecasting of a firm. So this is the correct answer is here functional requirement for the company. So we move to the next question. This is the question number 3. For the question number 3, to achieve in purchasing and transportation, goods may be purchased in larger quantity than the actual demand. This is the continuation, quality, cost efficiency, and potential value. So the C is here cost efficiency for this case. Then move to the next case. This is the MCQ problem of the question number 4. This is the MCQ problem of the question number 4. And which among of the following objectives of the enterprise resource planning system? Enterprise resource planning system. So here are the 4 options is given. This is the manage purchase order, control the flow of dependent demand inventories, organize the external management information, and the balance supply and demand. So here D option is the correct option. This gives the balance supply and demand. And move to the next. This is the question number 5. Which among the following models is used to calculate the timing of the inventory order? Here 4 option is given. First one is economic order quantity model, fixed order quantity model, C option is here reorder point model, and D is fixed order inventory model. So the C answer is, this is the right answer, and it gives the reorder point model, right? And then move to the 6th question. The type of inventory method that comprises more number of accounting transaction is known as periodic inventory method, proportional inventory method, finished goods inventory method, and fixed order period inventory method. So for this case, the correct answer is here B. B is the correct answer. This gives the proportional inventory system for this case. And then move to the question number 7. In the ABC analysis system, and the B category stands for outstanding importance in value, comparatively unimportant in the value, comparatively important in value, and the average importance in value. So D option is here right option for this question. And then move to the question number 8. Which among the following is a quantity of a specific item that is ordered from the supplier and issued as a standard quantity to the production process? This is the safety stock, lot size, standard deviation, inventory control. So the correct answer is here lot size. This is the correct answer for this question. And then move to the next question, question number 9. And in the question number 9, the economic order quantity formula is taken using differential calculus, integral calculus, vector calculus and the multivariate analysis. So this is a formula taken by this differential calculus. So A is the correct answer for this question. Then move to the next question. This is the question number 10. And which among of the following component is calculated as the sum of fixed cost that happens each time an item is ordered? This is the carrying cost. 4 options is given here. First is carrying cost, ordering cost, holding cost and storing cost. The correct answer of this here, order cost. B is the correct answer. Then move to the these are the references I have taken for this lecture here, and go through references and find the more information about this related question, and then I am very thankful for you to listening this lecture. So thank you all of you. Thank you.